use the ML formula to estimate the modulus of the integral of e to the z dz along a contour C, where C is the circle centered at I of radius 2. So if we have a contour integral, then the ML formula says that the modulus of the contour integral is less than or equal to m times L, where the modulus of f is less than or equal to m on the curve, and L is the length of the curve. So we have a circle of radius 2. So L is going to be 2 pi r, which is 4 pi. So that's L. Now we have to figure out M. Now notice our circle, we don't have a direction. It doesn't say clockwise or counterclockwise. And that's because when you're estimating the modulus, it doesn't matter what direction. Changing the direction would just put a minus sign and it doesn't change the modulus. So we need to figure out the maximum modulus of e to the z on this circle. So the modulus of e to the z is the modulus of e to the x plus iy, which is the modulus of e to the x times e to the iy, which is the modulus of e to the x times the modulus of e to the iy. The modulus of e to the iy is 1. The modulus is 1. And the modulus of e to the x, that's just a positive real number. So it's itself. So e to the x times 1. Now the function e to the x is at its maximum when x is at its maximum. And on a circle centered at I of radius 2, well, okay, that's not a good picture because the x-axis, if the radius is 2, it goes down here. So the maximum value for the x-coordinate on the circle is 2. The circle, this point here is 2 plus I. Over here we have negative 2 plus I. Radius is 2. And this is I. So this is 3I. And down here we have negative I. So those are some key points on the circle. And so the maximum x value on the circle is 2. So the modulus of e to the z is less than or equal to e squared on the circle. And so the modulus of the integral of e to the z dz is less than or equal to e squared times the length of the circle, which is the circumference of the circle, 2 pi r, which is 4 pi. So 4 pi e squared is the maximum value of the possible, that's the modulus of this integral is less than or equal to this amount.